Welcome to The Explainer. Today, we're going all the way back to the beginning, to the original 9-page paper from 2008, published by the totally anonymous Satoshi Nakamoto. Now, this is the document that didn't just introduce Bitcoin, it proposed a completely new way of thinking about money itself. You have to remember, back in 2008, this question was, well, it was kind of out there. The paper, called Bitcoin, a peer-to-peer electronic cash system, proposed something truly radical. The goal wasn't just to make a new currency, but to build a system that could work entirely on its own, with no bank, no middleman, no trusted third party whatsoever. So, to really wrap our heads around this, we're going to walk through it just like the paper does. We'll start with the problem it was trying to fix, then look at the building blocks of the solution, face the single biggest challenge head-on, and then see how all the pieces click into place to create a secure and, well, honest system.
Okay, let's dive right in. Section 1, the problem with digital money. To get why Bitcoin was such a big deal, you first have to understand the core weakness it was built to fix.
I mean, think about it, right? If you hand me a $20 bill, that's it. The transaction is done, it's final. But online? Poof, totally different story. Every single payment you make has to go through a financial institution, like a bank. The paper points out that this creates huge problems. It adds costs, sure, but the bigger issue is that banks have to deal with disputes, which means all transactions have to be reversible. And it's that very reversibility that opens the door for fraud and makes tiny online payments totally impractical.
So the paper's first big idea was to completely redefine what a digital coin even is.
So in this new world, a coin isn't some file on your computer you can just copy-paste. No way. Instead, a coin is its own history. The paper wants you to think of it like a public title for a piece of property, where every single owner is listed, one after another, in this unbroken chain that anyone can check. Each new owner gets added through a secure digital signature.
So how does this actually work? Well, say you want to send a coin. First, you take the digital fingerprint, the hash, from the last transaction. Then you combine that with the other person's public address. Think of that as their account number. And here's the magic part. You sign the whole thing with your secret private key. That's your unique password that proves you actually own it. And boom, you've just created a new, locked entry in the public record, showing the coin has a new owner.
Okay, but this whole chain of signature thing, as cool as it is, creates a massive problem. I mean, the central problem for any kind of digital cash.
And here it is, the absolute core of the issue. Without a bank in the middle, how does the person getting the coin know that I didn't just send that exact same coin to someone else a second earlier? Right? What stops me from just spending it twice? This is the double spending problem. And if you can't solve this, you don't have digital money, period.
Now, the old school way to fix this is pretty obvious, right? You just have a central authority like a bank or a mint verify everything. But, wait a minute, that just throws us right back to square one, relying on trust again. That's the very thing we're trying to get away from.
So Nakamoto's paper suggests something totally different. Forget the boss. What we need is consensus. We need a way for everyone, and I mean everyone in the network, to agree on a single shared history of every single transaction, in the exact order they happened. Whichever transaction came first is the one that's real. The second one is invalid. Simple as that.
And that brings us to, honestly, the most brilliant part of the whole paper, the solution. A system built not on trust, but on pure, cold, hard mathematical proof. The whole solution really starts with this idea of a timestamp server. The best way to think of it is like a decentralized public notary. It basically scoops up a bunch of recent transactions, puts them into a block, and then stamps that whole block with the unique digital fingerprint, a hash that's tied to a specific time.
So this hash proves that all those transactions inside the block existed at that exact moment in time.
But here's where it gets really clever. When you go to create the next block, you have to include the hash of the block that came right before it. And this is what creates this incredibly strong chain. See? Each new block is now cryptographically chained to the one before it. So if some bad actor wanted to go back and change an old transaction, they couldn't just change that one block. Oh no, they'd have to redo all the work for that block, and then for every single block that came after it, they'd have to literally outrace the entire network, which, as we'll see, is pretty much impossible. Okay, so who gets to add that next block? You can't just let anyone do it, or the system would be chaos. This is where proof of work comes in. To earn the right to add a block, you have to solve an incredibly difficult computational puzzle. It's like a global lottery where computers are all just guessing numbers as fast as they can. And winning that lottery requires spending real-world resources, serious computing power, and a lot of electricity.
So let's put it all together. Here's how it works. New transactions get broadcast to everyone. Computers on the network, we call them nodes, gather up these transactions into a potential block. Then, all those nodes start competing like crazy to solve that hard math puzzle. The first one to find the solution gets to broadcast their winning block to the rest of the network. Everyone else quickly checks that it's valid, adds it to their copy of the chain, and immediately starts working on the next block. The race begins again.
And what's so cool about this is that proof of work is basically a voting system, but it's not one person, one vote. It's one CPU, one vote. The longest chain, the one that has the most computational work invested in it, is always considered the truth. The official history. Majority rule here is decided by pure processing power.
Okay, so we've got the how, but that still leaves a pretty big question. The why. Why would anyone spend all this money on computers and electricity just to maintain this network? Well, the paper's answer is an absolutely brilliant incentive structure. There are two big incentives. First, if you're the one who wins that computational race and adds a new block, you are rewarded with brand new coins. This is literally how new Bitcoin is minted into existence. And second, you also get to collect any small transaction fees that people included with their payments in your block. This is genius, right? It makes it way more profitable to be an honest player and help secure the network than it is to try and attack it.
And the security of the whole thing just boils down to probability. The paper actually does the math, which you can see right here. Look, an attacker with, say, 10% of the network's power, yeah, they have a 20% shot at getting the next block. But what about creating a fake chain that's 10 blocks long? The probability drops to, well, basically zero. It becomes computationally impossible to cheat the system after just a few blocks.
And that brings us right back to the paper's incredibly simple but powerful conclusion. You take all these pieces, the chain of signatures, the proof of work, the incentives, and what you get is something that many thought was just impossible, a way to send money online without having to trust anyone.
You know, in the end, this white paper was about so much more than just a new kind of digital cash. It was really a blueprint for a whole new way of reaching agreement in a digital world. By moving from a system based on trusting other people or institutions to one based on pure cryptographic proof, it just blew the doors open for what's possible. And it leaves us with this huge question. In a world where we don't have to trust, what else can we build?